Hello friends, this is Rupesh and you're watching C++ video series on C++, and today's topic is inheritance in C++. And this video is going to be a very basic introduction part of inheritance where I will explain a single inheritance example and rest of the examples will come in coming videos. So here we are going to understand what is the need of inheritance and one basic example. So this is the core feature of object-oriented programming. So this is not only in C++, it is there in Java, Python, or to say all the programming languages whichever supports object-oriented programming. So the first question comes in mind is what it does. So it inherits the features, properties or characters, whatever you call, of base class into derived class. So base class means you will be having some class like class A and another class B, and you are inheriting that class inside your own class. Okay, so this class is called base class and this is called derived class, or you can call this one as parent and this one as child. So either you use this terminology or this terminology. I am familiar with this one, so I'll be using this one. So there is a class and you are inheriting it inside your class. So this is your class and this is some another class, and maybe this also was created by you only. Okay, and we'll see how to inherit that. So let's go through the points and why we use inheritance. One of the biggest reason is code reusability. It was initially created for code reusability and it is used for creating interfaces also, but I won't discuss that part because it will be little too much if you are beginner. So if you want to know what all you can do with the inheritance, I'll create another video maybe for uses of inheritance. So the terminology is base or derived, as I explained, or parent or child. Okay. So having said that, we have number of inheritance type. So there is something called single level inheritance or single inheritance. Another is multi-level, multiple, hierarchical, hybrid, multipath. So in single level, a derived class with only one class, base class, is called single inheritance. So the example we saw here is the example of single level inheritance because we have one base class and one derived class. Okay, so I'll just simply write all those types of inheritance so it will be easier for you guys to understand. So in single inheritance, we have one base class and another one is derived class. So only this much. So that is called single level inheritance or single inheritance. And in multi-level inheritance, a derived class with a base class and that base class is a derived class of another is called multi-level inheritance. It is nothing but multi-level. My writing is not that good, but that point is just like this. You have A, B and C. There is this another class which is inheriting B now. So this is multi-level. There is not single inheritance, there are multi-inheritance. Multi-level inheritance. So B is inheriting A and C is inheriting B. And you might be thinking, what if I am inheriting this C into D? Yes, then also this is multi-level inheritance. So no matter how many levels are there, if they are in this order, they are multi-level inheritance. So let's look at another inheritance. Another one is multiple inheritance. Multiple inheritance is nothing but a derived class with multiple base class is called multiple inheritance. What it means? Let me just give you this multiple inheritance. In multiple, you will have several base classes and you will inherit those base classes into one derived class. So this is B1, this is B4, and you are inheriting all these classes inside your derived class. Okay, so this is multiple inheritance. You are inheriting multiple base classes into single derived class. Okay, so it is very easy to remember all these things. So the fourth one is this hierarchical inheritance. In hierarchical inheritance, there will be multiple derived classes with same base class. Okay, so that would look something like this. Hierarchical, and As I said, there will be single base class and there will be multiple of derived classes, and this is base. So reverse of multiple inheritance is called hierarchical inheritance. You can see that. So this is how you denote the inheritance. This is the symbol of denoting that this particular class is inheriting this class. So this is the fourth one. Let's look at the fifth one. It is hybrid inheritance. So it is the combination of multiple and hierarchical inheritance. So as you can see, if you will go for multiple and hierarchicals combination, it would look something like this. So hybrid would be the combination of this one and this one. So let me draw the combination. This one is inheriting this one, and this one, this one. So something like this. So if this is the structure of your inheritance, that is hybrid inheritance. And don't think it is too much to remember. When I was studying, I also thought that, okay, these many types of inheritance, oh my god. But when I really started working on them, studied 2-3 times, they become really very easy for me. And when I was studying C++ that time, I was studying it from some books, okay? So no videos, nothing, internet was not that easy, and no one was there to explain me like this, what I'm explaining to you here. So enough talk, let's look at the last one, and that is multipath inheritance. So multipath is like a derived class with two base classes, and these two base classes have one common base class is called multipath. I know this is a little confusing, but I will sort out that doubt. So multipath, there will be this base class. So we have inherited these two, and then we will inherit these two into further this one. So this is, let's make it A, B, C and D. So this is a multipath example. Why it is multipath? Because this A is coming inside this D from multiple path, from B and from C. Okay, because A is there in B and C both, and B and C are inherited into D. That's why this A is coming from multipath. Okay, so this A is coming in D also, but not directly, indirectly. So this is the example of multipath. We'll see all these examples in detail when I'll explain each and every part differently. And as this is an introduction video, I'll keep it this much only. So far we have seen what are the types of the inheritance. Now let's look at the modes of inheritance. What do I mean by mode of inheritance? For that, I need to give some example here. So let me just create two classes. I'll quickly create them. So as you can see here, we have base class and derived class. We have not inherited anything so far. So let's see what are all these inheritance types are. So if we will use this public, or let's see how to inherit first. So this is the syntax for that. You have to write this colon and write the mode of inheritance you are using. Okay, so it would be like public if you want to inherit base class with mode of public. So public and then name of the class, what you want to inherit. So this is the syntax. You have derived class and then inheritance mode and what class you are inheriting. Okay, and then your class starting curly bracket will start. So this is the mode. And if you don't know what is public, protected and private keywords are, I'll strongly recommend please go ahead and understand the meaning of these, or I'll quickly tell you this. So if you have this public data member inside your class, so let's quickly create that public and integer x. So this particular data member is public inside your class. So it means it is visible to everyone. I mean, you can access this particular x inside this main function or any other function because you have made it public. So anyone can see this. So that's why it is visible to everyone. But if it is protected instead of public, if you wrote protected, in that case, this is visible only to the current class. So it means in base class. So if base class function, or to say data members, wants to access this particular data member, they can access that, or the derived class only. It means if you have this base class and you have inherited that class inside another class. So in that case, if you want to access this X inside this, you can do that. But only restriction is you cannot access this X outside this class and outside this derived class. It means you cannot access inside main. Okay. So this is one more level of restriction, because public doesn't give any restriction. Protected gives one restriction, that you cannot access this integer X from outside this class, but you can access it if you have derived this class inside some another class. Okay. What I mean to say is, if you want to print, you can simply print this X. Okay. Because this print belongs to this derived class, and then this print can access this X. But if you want to access inside this main, you won't be able to do that. So that was protected access specifier. And yeah, these three things are access specifier. You specify the access type of your data member or your member functions, and these access specifiers are used to specify the type of inheritance, not type of inheritance, mode of inheritance. What is the mode of inheritance here? It is public. If you want to make it protected, you can make it protected. If you want to make it private, you can do so. Okay. So this particular table is used to identify if you have derived publicly, then what all members will come inside this. What I mean to say is, if suppose inside base class you have some private data member, let's make this private, and let's suppose you have this derived class and your inheritance mode is public inheritance. Okay, so this is full inheritance mode row. Okay, so in public inheritance case, if you have private data member inside your base class, that is not going to inherit. Okay, so this is the result. But if you have private, it will not be inherited in any type of mode. See, if it is private mode here, I mean, if I will write private, then also you cannot access whatever is private inside base. Okay, so if it is private, not inherited, not inherited, not inherited in all three types of inheritance mode. Okay, so here you write the inheritance mode. So if you're writing public, private, protected, and whatever is private here, it will not be inherited. So this is the table. It is very easy to understand this table. So let me just show you that if it is public mode, and let me give you the example. We should go with the examples, right? So let me compile this. It is saying that one error generated and declared private here. It means you're trying to access this X here. You can see that it is giving you the errors exactly what I told you. So X is accessed here, but it is private. So you cannot do that. Okay. X is private member of base. So this is the error. So we cannot do this. So if it is private, you can see whatever mode you use here, private data members are not going to get inherited. Okay. But let's suppose you have protected. So let's make this protected, and this X is protected now. And let's suppose you're inheriting it inside derived class using public mode. So this first mode. So this protected data member, which is of base class, will become protected inside derived class. So protected will become protected, but you can access this X now. Okay, so let me just compile that. See, it has finished compilation. It means there is no error. Okay, so this is how it works. So if it is public and you are inheriting it with public mode like this, in that case, that data will be public in your class also. And in protected case, yeah, I forgot to mention, this protected data here is inherited as public, so it becomes protected. What it means? It means that only this derived can access this X. You cannot access this particular X from outside this derived or outside this base. What I mean to say is derived object d and d.x should be printed. And if you will try to access that x which is coming from top, you won't be able to do that because you are trying to access this particular x outside this derived. So let's compile now. See, it is giving you the error. See, it is telling that x is protected member of base. So you cannot do this. And as I said, if this is public, then everyone can access that. This derived can access that x, this main function can access that. So let's make that and verify it. So if it is public, I'll compile this. Oh, one error is there. What is this? Okay, some typo has happened. ENDL. Okay, see, it is printing 0. The point is you can access it. Okay, I think you are getting my point, right? Or if you're not getting it, revise this video 2-3 times, then you will be able to understand this very clearly. It doesn't come in first time. Okay, so don't panic. So you saw that if we had this protected here and we are trying to access this here, we can't do that. But we were trying to access that x here and we was able to do that. And just to demonstrate that, d.print. So if I'll compile this, what is this error now? Okay, this print is, again the access specifier problem. One more thing guys, here I have not given any access specifier for this particular function. By default, classes will make everything private. Okay, so that's why it is giving me the error. Print is private member of derived. So you cannot call from outside. Private means it is accessible from inside class only. Okay, so let's make it public. So this is how you make it public. So now this print function is public and we can call that. Okay, and here we can see that it has compiled, but it is printing some garbage value. That is not the issue. The point is we are able to access this x inside derived. Okay, because it is protected, and protected data member of base class become protected inside derived. But it is coming inside derived. That's why you are able to access it. Don't think that it is becoming protected here. So how you are accessing it? It is becoming protected here, and if it is becoming protected here, it means you are not able to, you are not allowed to access this particular x outside places. From here, from main or something. Okay. Now let's look at this public one. So if it is public and inheritance mode is also public, it means if this is public and your inheritance mode is also public, then your data member is becoming public inside derived class. Okay, so this x is public here. It means you can do something like this. Let me do this. So as this x is public inside derived, so using derived object you can access that publicly, and this is public domain. Okay, so let's compile that. See, it has become 0, so there is no error. And similarly for all these things, like if you have data member as protected and you are inheriting it as private, then it will become private inside derived class. Okay, so this column is for derived and this is also for derived, but different mode. This is private mode, this is protected mode. Okay, so if it is protected, it will become private in private mode of inheritance. If you will write private here and this is protected. So if this is like this, this particular x will become private here. Okay, so you might be asking, what is the use of making private here or protected here? So if it is becoming private here, you cannot inherit that further. It means if you have some another class derived 1, and if you are inheriting this as public like derived, in that case this particular x will not derive here. So if you will have some another public print 1, and if you will try to print that, you won't be able to do that. So let me just show you that. I need to write this void here. If I will compile, what is this? So many errors. Oh yeah, it is giving you the error just because of these things, because we have changed this access specifier here. Okay, so let me compile this again and see if it is okay. No, it is not okay. Oh yes, this is giving you the exact error. You cannot cast derived 1 to its private base class base. So the error is here. See, it is print 1 and you're trying to access this x. So it is not allowed. And in compiler term, it is telling that I cannot cast derived 1 to its private base class. So another way is it is not allowed because it is private here. Because you inherited privately, so protected become private here, and now you want to inherit this one here and trying to access that x, so that x will not come because that access has become private here. Okay, so this is how it goes. So I think you got the points. So as I said, I will be giving you the example of one level of inheritance, which is called single inheritance. So let's look at that example. If this is becoming very big video, pause it, go for some tea, coffee or water, come back and watch again. And that's what I'm going to do now because I'm tired of talking. So I'm back now. So I wanted to discuss this with single inheritance, code reusability. There is a traditional example to understand this topic, and I'm also going to use that particular example only. Okay, so let's look at that example. So that example is, let's suppose you have some animal class. So what are the functionality of animal classes? Animals, they eat, they walk, okay, and they do so many things, but we'll take these two examples only. Okay, so they eat and they walk. Now let's suppose you wanted to create so many animals classes. I'll take only cat and dog. So cat also walk and eat, and dog also walk and eat. So if you are supposed to create cat and dog classes, you have to give walk and eat here and here also. Walk and eat. Okay, so these are the functions. So if you was supposed to create two class cat and dog, then as you can see that you are creating similar functions again and again. Let's suppose if you are creating a dinosaur. Okay, so in that also you will have this walk and eat. What I mean to say is, if all these classes have some common property in them, then what we should do, we should create a common class. Let's say it is animal, and we should inherit that in our class. That is the best use of inheritance. So you won't write this walk and eat in every class. What you will do, you will write in particular class and you will call it animal and derive that class inside different classes. So the benefit is you don't have to write those similar looking functions again and again. And one more point, if you want to give some specific function to this cat or dog or dinosaurs, you can do that as well. So if you will take that example, that could be like talk. So they all will have talk, but they all have different talking way. Okay, so this is also talk, and here also it talks, but it is like wow. So it is different for this one and this one. Okay, what I mean to say is cat will do something like meow, dog will be bow bow, this is bow. So they all have some similar function, talk and talk, but they all do it differently. Our point was whatever common thing is there, we will put in some base class and inherit that, and whatever is not common, we will put inside individual class. So let's see the example here. I'll quickly write the code for you. So as you can see that we have this dog, cat and dinosaur class and this animal class. Okay. Similarly, what we had here. Now, I have not given any inheritance here. So let's do that and inherit this animal inside all these three classes. And I'm going to use public for that. And yeah, one more thing. If you are inheriting it like this, just simply like this without writing anything here, then also it is possible, but by default, if it is class, your compiler will assume you are inheriting it in private mode, okay? Not in public mode. Remember that. In structure, it is by default public. So if it is not class, if it is structure in C++, by default it is public inheritance. So we have to give public here, okay? And similarly for these classes, so I'll just simply copy and paste. I don't have much time. This video is getting a little bigger, I know that. Yeah. So what you expect here? Exactly. You are having this eat and walk function in all these classes. So let me give some message, eating, and here walking. So it will be easier for us to understand this. Now let's create dog class D and cat class C and again dinosaur class DI. And if you will print D dot eat, you would be able to do that. And C dot eat, and again dinosaurs eat. So they all eat, right? So let's compile that and see. It is telling that eating, eating, and eating. So the point is this eat function is not there inside dog, cat, and dinosaur. It is coming from animal. Okay, so it was common in all the classes. That's why we put it inside one top class and inherited that. So we don't have to write it again and again. That's the only point. That's the only point of code reusability. I know it has made your points so clear. And yeah, one more thing. If you will call this talk, and as I said, it is different for every animal. So let me just give here talk and here also talk. So if you will compile now, let's do that and see. It is bow, it is meow, and now how. So they all have their specific talk also. Okay, so this is how you go with inheritance. This is not the only use. We created for interfaces also, but I don't think it should be included in this video. I will create another video, so don't worry. If I have not created it after some time, you can please remind me for that. I'll do that. Okay, so let me check if I'm missing some point here. I don't think I'm missing. So we have covered this single level inheritance, but actually it is not looking like a single level inheritance. This is not a single level inheritance. Can you guess what type of inheritance it is? It is hierarchical inheritance. So in hierarchical inheritance, there was only base class and multiple of derived classes. So I think you got the point. We use inheritance for code reusability. I know my spelling is maybe not correct or my writing is not good. So this is one of the reason. Another reason is we can easily create the interfaces. I'm just writing that so that you can keep this in your mind, and I'll explain this part in coming videos. So I think we are done now. Thanks for watching. If you like the video, don't forget to hit the like button. And yeah, make sure you subscribe to my channel so that you will get the notification for upcoming videos like this. See you. Bye-bye.